Hello everyone. I hope we've been good in life. God being so good. This is my next lecture on trigonometry. And I'm so excited with the fact that we've treated 5 um, outlines out of the 10 outlines on our algebra. It means we are making progress. So we've looked at set, indices, logarithms, sets, and today I'm looking at trigonometry, or someone say trigonometric functions. I'll have 2 videos for this so that it will be in short form, not to bore or weigh you off with the subject. And so flow with me in this first lecture video on tricks. Now the sub-content is to take you through introduction to some ratio and angle measurement and then fundamental identities. But for this lecture video, I'm going to take the first 2 and I'll take another lecture video on the identities for you. I hope that is fine. So let's quickly go through the introduction. I came across this funny or interesting meaning to trigonometry as a Greek word that says the tri, like we say tri, so 3. The gono is sides, and then the metry is a measure, like a geometry. So you realize it's a 3-size measure. 3-size measure. If it's a 3-size measure, it can't be a rectangle shape. No, because that's a 4. It can't be a square. It can't be it can't be a circle. No, it can only be a triangle. It means that all our emphasis will be looking at the shape of a triangle and then the measurement of a triangle, most specifically the right angle triangle, as I have seen here. So that is the whole idea of trigonometry. And so we want to study the relationship between the size and the measurement, the angles. If I say sides, these are the sides of the triangle. So the height, the hypotenuse, and then the base. And the theta is my angle, the relationship between these 2 guys, size and then angle. Before we go through the angle, you realize that let's say there's like an eye. It is moving or is pointing to a particular direction. That becomes the opposite. It's like the English word, this building is opposite this building, and so the eye or the angle is opposite it's opposite this side of the triangle, and then it's adjacent to the base, and then the longer length become the hypotenuse. So always take the opposite as where the angle is being tilted to, and then its other side become the adjacent. I hope that is well understood. Okay, so with that, let's look at the measure. Let's take the theta first before we look at the size. This theta angle measure is of 2 forms. We can measure this theta in a form of degrees, so not degrees Celsius, so just degrees, or we can look at it in terms of radians. So you realize that if you use a calculator, you have to change the mode to either degrees or radians for your computations. Yeah, and that is the effect of your angle. If I have a full rotation, we mostly have a 360 degree, and then its equivalent radians is 2 pi. So let me use the equivalent symbol. 360 degrees and then 2 pi. The relationship here is of this form. So let me label it as equation 1. If I take a degree over 360 and radians over 2 pi, by a simple change of subject, I can find degrees in terms of radians. So this idea is that you want to express one measure in terms of the other. So I can measure degree in terms of radians, or I can measure, if I'm given the angle in radians, I can convert it to degree. That is the whole idea. So let's see, by change of subject, I just need a cross multiplication. So degree will cross multiply radians 2 pi and then 360. You can easily do this conversion. I believe you. So how did I get the 180 over pi? You realize if I want the degree alone, I have to multiply 360 by the radians over 2 pi. 2 cancels 360 and I get 180 over pi radians. So that is what I have for equation 2. You can follow the same approach and then you have equation 3. Try that out for me. If you're able to get it, it means you are good to go. Okay. So that is what I have already talked about for equation 1, 2, and then 3. That is the conversion, moving from one measure to the other, as simple as that. So let's take examples here. Let me move straight to the slide. I think slide 5. You are given sorry for humming so much. First, you are given degrees, 30 degrees, and asked to write in terms of the radians. It says write 30 degrees in terms of radians. It means you want it in a form of pi's. You want to do away with the degrees, and what do? I have to use equation 3. Equation 3 says just multiply your degree by the pi on 180, and whatever answer you get, it will be in terms of pi's. You can use calculator for this. And look at equation 5, the same degree to radians. So now instead of 30, I have 90. It says if you want the equivalent in radians, just multiply whatever you have by the degrees 90 and you're good to go. And then the answer I'm getting is pi on 2, because 90 cancels the 180. Okay, don't forget the 180 is in degrees, so it cancels out and I get pi on 2 radians. So you can quickly go through equation 6 and equation 7 for your own good to see if you understand and you get the answer. That is the best way we can learn. Okay, so if you are given radians, it says you can have to use equation 2. You are given radians and you want to find its equivalent degrees, you can only use equation 2. So you multiply your radians by 180 on pi. Take your time, look at my slide 5, and then try your hands on. If I'm wrong with the answers, don't forget to prompt me in the comment section. Okay, thank you. Now let's go to the ratios. We are done with the angles. For the ratios, in some textbooks they use the trigonometric functions. There are 3 giants or solid functions we want to use: the sine, the cosine, and then the tangent. And based on the right angle triangle, so if my theta is here, means my theta is pointing or looking this way, and so this becomes opposite, and then 8 base becomes the adjacent, and then my hypotenuse. Based on where these sides are, you can use the sine or the cos or the tan. To make life easier for us, we came across this acronym, or we are used to this acronym called the SOHCAHTOA. I'm sure it rings a bell. So the SOHCAHTOA means the S for sine, the OH means for sine, you look for opposite and then the hypotenuse. The K means C is the cosine. Cosine uses adjacent, A for adjacent, H for hypotenuse. The TOA means opposite, the O for opposite, the A for adjacent. So O for opposite, it makes life easier. A for adjacent, H for hypotenuse. Is HYP. That is how life is. And so we're going to use these trigonometric functions to evaluate certain triangles. In the first example, look at the figure A and then B. You have an angle given and some missing sides, and you want to find this missing sides or this missing length. What you have to do is to look at or extract the information given. So from my triangle here, I have this is pointing this way, it is pointing this way, and so it means I have the opposite given. So that's the first information as x. I don't have the base, but I have the hypotenuse given as 5. Since I don't have the adjacent, I can't use any formula that deals with the adjacent. If you go to the SOHCAHTOA, there's O, there's H here for these two. It means only the sine can help you solve this problem. And so you take the sine 30 degrees is opposite over the hypotenuse. So x over 5. And by change of subject, a simple change of subject, you can find x. This you should be able to do by change of subject. And you're going to get 2.5. If I want to solve for b, you realize that the angle 52 is still pointing this way. So it means that I have opposite given. But in this case, I have the adjacent given as the x. I don't have the hypotenuse given. So you realize that I have some opposite over some adjacent, OA. If I go through the SOHCAHTOA, the only thing I can use is a toa. That means tan. Did I do something wrong? I have opposite and then, oh, so why did I write cos here? Forgive me. So I can only use the tan function. Thanks. So that will give me the opposite over the adjacent. So 16 over x, and by change of subject, I can find x by doing a cross multiplication. And that is what I'll have here. 16 on cos. So instead of cos, I have tan 52. Let me just rewrite this thing well. So I have 16 over tan 52 giving me 12.5 with some decimals. So that is how simple it is. Okay. Now there are other cases where the angle is given and then you have to, the sides are given and you have to find the angle. So in these first two examples, the angle was given. So I don't know where to write the statement, but an angle was given and we have to find the sides. And the subsequent examples, the sides are given, it means the length are given, and we have to find the angle. So in the same way, you have to extract your information. Please, you take your time, don't be scared. So look at this drawing. You realize that this guy is pointing downwards. It means I have an opposite and side given, and I have its adjacent also given. I don't have hypotenuse. So this two is O and then A. What word can I use? Can I use a so? No. How about ka? No. But I can use a toa. It sounds funny mentioning them. So it means I can use the tan theta to give me opposite over adjacent as I have here. And by change of subject, if I want theta, it means I have to find the tan inverse of the answer. And that is what I have here. In this case, you use calculator. If I want it in radians, you can convert. Now theta is 53.13 degrees. If I want it in radians, what do? I multiply by pi on 180. If you've forgotten, you go back and then you check. If I want it in radians, I use this equation 3. Where am I? So I would have written pi on 180 degrees times the 53.15 degrees, and I have it in terms of some pi's. I'm not so sure of the answer, but that is what you can do. Now let's solve the b. You realize that my theta is pointing this way, and that is the opposite, but I don't have a value there, so it means I can't even use it. But interestingly, I have the adjacent value given as 1, and I have hypotenuse given as 2. So which of these acronyms can help me get A and then H? It is the CAH. So it means I use the cos. So CAH, the cut. So cos theta equal to adjacent over hypotenuse. So 1 over 2. If you swap positions and then you make it hypotenuse over adjacent, trust me, your calculator will not say it's an error. It would give you an answer. So it's always the first letter over the second letter. Probably I didn't make mention of that. So the first one over the second one, the first adjacent over the hypotenuse, the opposite over adjacent. That is how you make it. If you swap it, garbage in, garbage out. So please, you take note of that for me. And the same way, if I want the tan, if I want the theta, I take the cos inverse of 1 on 2 and I get 60 degrees. And yet you can convert this to radians, don't forget, if you want radians form. Okay, that's how simple the ratios and angles are. And that brings me to the last section of this video, that is the problem of the day. So I have it as the first problem. Again, I told you, when you look at a word problem, you take your time, you read, you extract, and then you solve. So let's look at this. A person stands 20 meters away from the base of a tall building. So I've drawn, I have my tall building here. Whether you like it or not, that is my tall building. there's just a way to have a building. We are used to this. And this is a person, the human being. So I'm just using a graphical way to understand the problem. It says you are standing 20 meters away from the basement of the building, and then you are looking up. You are watching the roof of the building by some angle. So this is an angle of inclination. The angle is 35 degrees. You are watching by 35 degrees. It says, what is the height of the building? If you can see top, it means you can measure how tall the building is. That is the height. So if I want to bring it to the 3 size measurement, you realize I have a shape as this. So this part, the inclination, you standing here, and then the basement of the building, and that is what I have here. So we have the inclination 35, we have the base 20 meters away. We want to find x. That is a problem. So what information do we have? You realize that this is pointing here. Is the blue confusing? Let me use red. This is pointing here, so it means I have the opposite of the angle given. Do I have hypotenuse? No, so there's no hypotenuse, but I have the adjacent given as 20 meters. So which of these functions can I use? Is it the cos? Is it the sine? Is it the tan? What do you think you can use to solve this problem? If you know it, good for you. You can solve it out, and let's compare our answers in the comment section. Okay, so I think there's O, there's A. I've given you a clue. All the best in solving this problem. See you in the trig identities. Bye.